Alright, in this video I'm going to show you how to solve two linear independence videos. The first problem is, are the vectors 3, 8, 7, negative 3, 1, 5, 3, negative 1, 2, negative 1, 2, 6, and 1, 4, 0, 5 from the vector space of all 2 by 2 matrices linear independent? Well, see, the first thing we want to do is, or the thing that we want to do is to make sure that the only linear combination of these vectors is a zero vector. Okay, so we set it up with constants C1, C2, C3, and C4, where all of these multiplied, each of these vectors, as you can see by, because they're color coded, equal to a zero vector. Okay, after plugging these in, we get this equation. Okay. Now, the next step here, you want to multiply each of these constants with their respective vectors. Okay, so we get, alright, 3c1, 8c1, 7c1, negative 3c1, plus c2, 5c2, 3c2, negative c2, 2c3, negative c3, 2c3, 6c3, plus c4, 4c4, 0, 3c4 equals the 2 by 2 zero vector. Okay. Now, since each of these spots are now we want to put this into a system by looking at where every single the spot of each vector to where they compare to the 0 or 2 by 2 zero vector. Okay, so we get this system right here. Okay, now as you can see, this is a linear system, and what we want to do now is put it into an augmented matrix. Alright, so we look at the coefficients and the answers, and we plug in the 3, 8, 7, negative 3 into the first column, the 1, 5, 3, negative 1 into the second column, etc. Okay, till we get this. Okay, now to make sure that the only linear combination of these vectors is the zero vector, is we want to put it into reduced row echelon form. Now, if it comes out right, alright, it should come out to where it follows all the properties of a reduced row echelon form, and where all the zeros are not changed or altered in any way. So then this means that your C1, C2, C3, and C4 all equal zeros, and that means that it's linear independent. Now going to the next video, or next problem, or example 2. Now for problem 2, we want to see, are the R4 vectors 3, 8, 7, negative 3, 1, 5, 3, negative 1, 2, negative 1, 2, 6, and 1, 4, 0, 3 linear dependent. Now, you should pause it here, try to do it yourself from the previous question and see if you can get it. Alright, so hopefully what you did is you first remembered that you need it to put it into a linear combination where it has to equal the zero vector. Okay, so you do the same thing as before. You have C1 multiply the first vector, C2 multiply the second vector, C3 multiply the third vector, and C4 multiply the fourth vector. And it doesn't matter which spot you have it, it'll come out the same, or it should. And you have to equal it to an R4 vector, okay, or a 0 R4 vector. Okay. Now you multiply C1 into the first vector, C2 in the second vector, and all that, and you should come out to this, to where you you get the system like this. Okay. Now from here you get the coefficients and the answers, and you put it in the augmented matrix. All right. Use the reduced row echelon form in your calculator to make it easier, and what you should get is that it's linear independent. And those are the two examples I have.